Hi everyone, my name is Kartik and my channel is about mental models. I hope you're enjoying my videos. If you are, then please subscribe to my channel and please like and share this video with everyone you know. In this video, I'm going to be talking about the regression to the mean as a mental model. This mental model comes from the area of maths. In maths, the word mean means the average, and regression is a measure of the relation between the average of one variable when compared to another variable. Therefore, when we plot a graph, such as like this, when we plot a graph, we would, let's say, this is the average. The trend may be rising and falling across the average. So this is the trend. And so what we are seeing here is that the trend is an outlier sort of in these points, but then coming back to the mean. It goes away from the mean, but then it sort of comes back to the mean. So that's what I'm trying to explain in this mental model video. But this is not a maths lesson. So from the world of mental models, what we need to remember is that we can be misled when we observe the world. Learning to recognize when regression to the mean is at play can help us avoid misinterpreting the situation. What we might be observing is an outlier, so we might be observing the points out here rather than the average, rather than the trend. So we might be observing the trend rather than the average. Either an event that is very good, sort of up here, something that is very good, or very bad, something sort of down here. These events will return back to the average, but what we are observing is those sort of extreme points. And so this will mean that if an event is negative, there will be a natural increase. So if an event is negative, there will be a natural increase. So sort of these arrows here, there will be a natural increase in this return to the average. Now, the reason why I have only taken this point, and I haven't mentioned the positive points, I've just said the negative will increase and return back to its average. The reason why I mention this is because you may see a negative event. In reality, you might see something, or you might be involved in a situation where there is a negative event, and to turn it around, you may switch what you are doing. You might switch it around, you might change what you want to do. And this might, by switching it around, you might see that this results in a more positive outcome. So you start off with a negative, you switch what you're doing around, you make some changes, and that results in a more positive outcome the next time. And you may believe that it is because of your switch that we have got to this positive outcome. But it's likely that the event would have been better the next time anyway, because it was regressing back to the mean. And the new way of doing it, this switched way of doing it, is actually as equal as the old or the original way you were doing something. So at this is quite an important thing, and that's why I wanted to highlight this negative event or situation that might occur. So at this point, you're probably thinking why this happens, and more importantly, how we can make sure we are aware of regression to the mean when it does happen. Right. The answer to the first question is quite a simple one. It's because the correlation between two variables is less than perfect. So we've got variable 1 and we've got variable 2, but this I put an equal sign, this is not perfect. There are imperfections between these two variables, how they are related to each other, and it is in this imperfection that this exists. An example of this is, so if I put an example, let's say variable 1 is height and variable 2 is weight. So all adult men, so what I'm saying here is height and weight are not perfectly correlated. And the example is that all adult men will be taller and heavier than a 1-year-old baby. But not all adult men nor all 1-year-old babies will have the same height and weight. So generally, as weight increases, height will also increase, but it won't be like this. It will be like so. And that's what I'm trying to say. There is this imperfect relationship. The answer to the second question of how we can make sure we are aware of regression to the mean when it happens is firstly awareness. If we know about the phenomenon, then we will be mindful of regression to the mean taking place. Secondly is track record. Looking at the record of past performance of an employee or for an employee, or previous statistics for an event will be more reliable than one-off success stories or a short-term trend, going back to this diagram here, this graph here. An example of this is, let's say, the final game of the English Premier League from the 24-25 season, so the season that's just finished in the English Premier League, and looking at the match between Manchester United and Aston Villa. Aston Villa were 5th starting the final day in the league table. Manchester United were 16th. Aston Villa had lost 1 and won 3 of their past 4 matches, and Manchester United had not even won a game in their last 4 matches, having lost 3 and drawn 1. And so on league position and the short-term trend, it would seem likely that Aston Villa would win against Manchester United. Now, having said that, the track record of Aston Villa playing at Manchester United's home ground is that they have only won twice in the past 39 matches. So not looking at this short-term trend, but looking at the track record, Aston Villa have not won many matches. And that is the statistic, or that is what prevailed. And it was no different on this occasion because Manchester United won the match 2-0, even though their league position was not very good, and even though their short-term trend of matches played was not good compared to Aston Villa. So that's a very good visual example. So I wanted to bring that out. Now, both teams in this case, both teams moved towards their usual or expected performance, which is the average case for the scenario, that is Manchester United winning. A point to note more generally is that whenever a correlation is imperfect, the better performing will always appear to get worse, and the worse performing will always appear to get better. And you can sort of say that is the case over time as well. And so time is a key factor, and this is connected to sampling as well. If you want to know more about sampling, please watch my previous video. The link is in the description below. And so if you extrapolate small sample sizes from which could mean a short period of time, as I said, time is a key factor. So if your sampling is from a short period of time, then the sample data may not be a true reflection of the population, thus leading to an incorrect decision. And so anything can happen in the short run, especially in any effort that involves a combination of skill and luck. Finally, so the three things. Finally is extreme groups, where an event showcases an extreme population, such as someone in the 1%, top 1%, or an extremely disadvantaged or underprivileged group, then regression to the mean can happen here. And so we may mistake a specific policy or treatment as the cause of an effect, sort of something here, something like here. When the change in extreme groups would have happened anyway. So going back to this, we feel that there is some form of treatment or a switch. It can be compared to the switch case here. When we have that for extreme groups, we feel that the treatment has led to the positive effect. That's the cause of the positive effect. But in actual fact, because the extreme groups are at the extreme points, at the outlier, change in those extreme groups would have happened anyway through a regression to the mean, through them coming back towards the average. So any form of betterment or reduction from the sort of the extreme points, whether that's, you know, in an overly good place or an overly bad place, coming back to the average. And so that would have happened anyway, rather than the switch. So this presents a further fundamental question. How can we know if the effects are real or simply due to variability? And so the best way to measure this, in this case for extreme groups, is to use or have a different group, which is not extreme, but we can call it a control group. And this group of people would be a group that would move by regression alone. So they wouldn't be affected by any treatment or any policy or any other effect or any switch or anything. They would move by regression alone. And the idea is to then measure the movement of the extreme group against the movement of the control group and review this movement and sort of review if this movement is greater than what can be explained by regression alone or not. And so that's the way to find out if a policy or a treatment or a switch has worked. We test it against a group where only regression would be the effector of it. So just to caveat this point, it all sounds very simple when I talk about it, that we just take two groups, we just measure it, review the two against each other, and we get the answer. It all sounds very simple when I talk about it, but in real life, in reality, the effects of regression can be very difficult to extract from a scenario. And so it's not as simple. There is a lot of effort required. It's not as clean cut, but just want to say that this is a way to do it, even though it is difficult. And so there you have it, regression to the mean, why it happens, how we can be vigilant when it does happen, and thirdly, how can we know if the effects are real from some form of treatment or just sort of movement due to regression to the mean. And that's all for this video. I hope you liked this video. If you did, then please check out my earlier videos flashing on screen now. I'm sure you will like them too. And I will see you in the next video with another mental model. Thank you for watching. Bye bye.